So hi guys, it's me Deepak, and in this video we are going to build a digital classifier using TensorFlow like model from scratch. So we'll be using Python to build the model, and in the Android application we will use that model, and we'll build this application as you can see on your screen. So guys, we begin by going to desktop, and in desktop we're going to create a folder, and I'm going to call the folder TensorFlow. In this particular folder I'm going to create the Python file, and in this particular folder is where our model will be saved. Then we have to copy to Android Studio. So I've just created a particular file using Nano, and saved it. I'm going to use Sublime Text Editor for reading the code, and gonna compile it in terminal. That's what my usual flow is. That's how I usually code. So you can check. You can see how I run compile. I just save the code like print hello world, and if I write Python instead of Py, you can say it compile the code and it print hello world. And my Python version is 3.8.5 at this point, and I'll just quit out of this. And I want to install some particular modules right now. If you already have that on model, I want you to install NumPy, Matplotlib, SciPy, TensorFlow, and I want you to. And this is gonna take some time if you don't have, like, TensorFlow is really big, but it's gonna take some time, and after that you will see something like this. You will see that it's installed, and you can check if you have them by just writing Python and then see import NumPy. If you don't have them, then you will get error like no module name this. Like if I say Pygame, I don't have Pygame right now, so it's giving me an error saying no module name Pygame. I can then install pip3 pygame, and it's going to take some time, and then it's going to be installed. Okay, so it's going to install. I run Python again. I say import pygame, and it's showing me the version. So get rid of that and clear it. Okay, let's now finally. Okay, so I'm using Sublime Text Editor. You can just like search Sublime Text, and you can download Sublime Text. You can use PyCharm, Visual Codes. I I don't have any issues with that. It's your choice. We're gonna start by importing all those modules that I talked about earlier. So I'm gonna begin by importing TensorFlow. I'm gonna call it as TF. Second thing I'm going to import is Keras. So from TensorFlow, I'm going to import Keras. This is like a high-level API that it will be helpful in creating our neural network as well as for processing. And then I need to import is NumPy, Matplotlib, and random. So NumPy is like this module that is helpful when you want to do some calculation stuff, and Matplotlib is used for plotting. It's the name. So for visualizing our images, for visualizing our data sets is really helpful. And these are really fast. Like NumPy is, I think it's written in C++. Not sure. Let me just search it. Think it is this is really fast, and you there's a difference, like if you use list and numpy are faster, uh, but there is a limitation, like you can only have like one type in it. And then we're going to put random, that is also necessary, and you can just print something like hello to see if there is no error showing up right now. So just get it over it. So there's no error and it works. Okay, next thing I need to do is I want you to do is amnist is equal to curious dot datasets dot load. So I'm going to use this amnist dataset, and it's going to have like these images of like a lot of images of numbers, like 4 5 things, and it's going to have like label datasets. So it's going to also tell me that this particular image is of this particular digit, and I'm going to separate it between training and testing data sets. There are also like validation data sets that we use before testing it, but we're not going to that direction. We just have to. And I have this amnist.load data, and what we'll do is it's create a for loop and just visualize this data set out what we have right now. Let's see. So I'm just going to learn a for loop and see first 25 images of that training images, first 25 training images, just to get uh, see what we are working with right now. So what I'll do is we'll run a for loop, But before that, let's just first normalize this images. What I mean by normalizing is I will just divide it by the highest pixel value of the image, highest pixel value. So in this case, like a highest pixel value is 255.0. So I'm just going to divide it so that I have like the pixel values between 0 and 1. And it's really helpful for neural network because the weights are very small, so it works better if you have small values, probably between 0 and 1. So that's why we're normalizing it between 0 and 1. And then I'm gonna run a for loop now. So in range 25, and in the subplot, in subplot you're gonna mention like 5 rows and 5 columns of plot dot subplot uh, from that matplotlib. So that's why we mentioned as plot. It's simple, right? And 5 5 and I plus 1, and x ticks and y ticks. I'm gonna leave them like that only. Then we need to call I am show. So let's copy this vertex, and I need plot dot I'm show, and I'm gonna have this images in grayscale. So I'm also gonna mention like oh, for I have to mention like grid false, otherwise it's gonna like blocky image that I don't want. So plot dot same dot gray, and plot dot x label, and it's going to label this data set of ours. So I'm going to mention like train label I and plot dot show. Let's run. Okay, but arrow somewhere. Okay, should be yes here, and image is not defined. Okay, a typo, and okay, one more error. What is this? Sorry, it should be I here. So it's a whole list, so I have to mention what I'm in the index values. So now you can see, but I think there's a little bit overlapping, so let's fix that with fixed size. We'll define fixed size like 10 10 here, and then this will work, and then we can see it. So let's save this and run again, and okay, this is now better. You can see the images, how are they, and you can get what I'm trying to say, like, right? So this is done. Now I need to do is uh let's create our new architecture now. So what I want to do is create a function called create model, and in this yes, so in this create model, let's create a new architecture. I'm gonna go here start sequential, and here uh, let's create a first layer. It's gonna be, oh wait, first of all let's reshape the image, sort of like what I want to do is dimension, expand the dimension using numpy. So what I want to do is have it like uh, it's currently in 28 28. I want to bit like the 28 28 1. What I'm going to do is call this function in numpy called expand dimensions, and let's pass our images, and x is equal to 3. Similarly, I want to do this for our testing images as well. Let's pass testing images, and here also as well, here as well. And let's now create our model. So our input layer and input shape is now 28 28 1. So here is dot input layer, and then what I want to do is input shape is equal to 28 28. Okay, now we want a convolution layer, and in this what convolution layer does is it like I have like suppose I have like 3 cross 3 matrix and 100 cross 100 matrix. So 28 in this case, I'm just gonna put like 3 3 matrix on every 9 matrix. Like example, like just imagine like there are 3 cross 3 matrix, and is moving over that 100 cross 100 matrix linear in a linear fashion, then going down, then moving for every like how can I say this? How can you visualize it? I'm just gonna put like third filter, and this thing that is I mean it's like used for blurring and seeing image better. And what I'm going to do is use an activation function that is relu, and it is basically like y is equal to x for x greater than 0, and like if x is less than 0, is going to y is going to be equal to 0. So it's like imagine a line that is parallel to x-axis, that is on the x-axis for negative x, and it moves in linear fashion at 45 degrees when x is positive. I think I should put some images on while editing this. Oh. And similarly, I'm going to have another combination layer, and this time I've increased the filters. Filters usually increase as the volume, spatial volume increases. Uh, and like I'm not going like next layer is max pooling. Max pooling is about having like decreasing the spatial volume, and I'm going to have a two window, and in the two window I'm just going to take out the maximum pixel value. That's going to represent that 2 cross 2 matrix every same time. So it's going to half the shape of the matrix. Like if before this the shape has been changed to 24 24 64. This is gonna half it to bit like 12 12 64. You will see when I will call model summary function after I have compiled it. You can get better idea what I'm talking about. But dropout is used when you want to like you don't want overfitting. When you don't want overfitting, you use dropout function, and then we're gonna flatten this layer, this matrix, linear like linear array, and then I want is dense. Then we're gonna have like output of like 10 output, 0 to 9. This is what it represents. Dropout is overfitting means when you train a model, there are some noises, and you don't want to train your model that much that it think that those noises are also concepts. No, you don't want that. So we use this dropout layer. Also, I forgot to mention that I'm gonna have like softmax function as well. Now let's compile it. So for compiler, I need optimizers and loss functions. Optimizer I'm gonna have at this point is item optimizer, and loss function I'm going to use is sparse category of cross entropy. Sparse because it's in digital category, otherwise I would have gone for categorical. And what this does is it look at the probability distribution at this point and see what whose entropy. If the entropy is more, that means the probability of it being me is less, and use the log function to calculate the losses. So that's what we do here, and our matrix is accuracy. Yeah, this is basically what this network is about, and then we're going to return our model. Does it matter something? Okay, here, okay, done. And what I want is now gonna call this function from here. So our base model is going to be a model. So let's create model and base model dot fit, and train images, train labels, and epochs is only 5. And then I also have a validation data which is going to be our testing images and testing labels. Okay, let's print model or some. I mean, let's call model sorry function, and it's gonna tell us about our model. Okay, so we have made some typos here. I think sequential should be here. Then we need to call. There was some mistake like layer here should typo. Let's look at the code again. I think I have made a lot of typos here. Filters and kernel size is also something wrong here. Let's correct those. It should be kernel here, filters here, should be also as well there. Our dropout is wrong, and it should be testing images interestingly for fish. What I've done. Uh, validation. Okay, should be validation data here. Even mentioned it. Like should be validation data here. And let's save and compile it. Okay, so now it's working, and Morrison is going to tell us about the oh fish. It should be base model or model summary. Just let it run. We'll figure it out later. What we want out now is since our images are like it's not like going to be always like if I'm drawing on a particular image, I'm going to draw it at this like particular frame, like this particular area where these images are. Like in the example, these are like in a square box of like it should be like parallel to x. I mean, it should be like how should I say this? Like you draw a one, it should like those images don't have like what if I rotate the three a little bit? It's still a three, but can I visualize it? No, accuracy is going to drop. Or just shift the three little bit to the 45 degrees, or not like 45, like 30 degrees almost. It should recognize that it's still a three. 45, it's pretty weird now. So you get my point. Like if I shift the images a little bit, draw an image here and there, accuracy is going to drop. So what we want is to do some pre-processing and change our training and testing data set a bit, and we're going to train on that data again. So I'm going to create a new model, and then I'm going to train on that data. What I'm going to do is call for things like rotation range. I'm going to add some rotation, some shear angles, some right and hit shift. So width shift range, height shift range here. Rotation is x at 30, then 0.25 for width shift range and height shift range. And then I want is a zoom. They can be like 3, maybe a bit bigger than as well. And this is going to massively improve the accuracy. Uh, because if we don't have accuracy, it's going to be like about 40%, and we don't want that. I forgot shear range here. We want shear range as well. That's what we want for our data generator. And then I'm gonna create train generator variable, and I'm gonna set like data gen.flow, and I'm gonna pass my training images and testing train labels. Similarly for testing generator, I'm gonna say is like data gen.flow, and still running at this point. Test images and test labels, and I want you see the accuracy like 99 at this point, but it is pretty bad if you check it in practice. What we want is a base model to evaluate, and we want to evaluate our test generator. So not like test labels, but test generator, and it's going to tell us that the accuracy is really bad. Yeah, I told you like this. So the model should be like base model there, and save it. And I think you should run it again. Now let's see. Mm, okay, just let it run. And what we want now is we will create a new model, and this new model is going to be really good. Trust me. Uh, so I'm missing something here. Test generator is called the first called. Uh, okay, so let's create a new variable, new model. I'm gonna call it improve variable, and create model, and then I'm gonna compile it, fit, I mean, fit, and I'm gonna fit it with train generator, run the epochs, prediction that is gonna be test generator, and test generator, and this is and what I want to do is after this I've done, I want to convert it to TensorFlow model, but before converting it, I want to quantize this model, like reduce the space. Although there's a trade-off between space and accuracy, there's going to be an accuracy drop. So from I think it's dropped to 92 after quantization on the 89 almost, but it's worth some time the trade-off between space and accuracy. So I'm going with a context model. So what I'm going to do is convert result to lite dot converted from keras model, converter optimizer, and optimization is equal to tf dot lite dot uh, optimization dot default, all caps, and it's gonna convert it to. I mean, after I call convert function, it's gonna be converted. So let's create a tf context model variable, and I don't want many typos of checking again and again. Convert or convert, and after converting it, we're gonna write it in the file. We're gonna call it like f is equal to write optimization, f is equal to open amnesty f dot write, and wb like write f. Then we're gonna write like f dot write, and pass the model, and close the file. Okay, this is what we want, and how much longer it's gonna take? I think it is almost done. Uh, let's see it is. Hmm. I don't think I have many typos anymore. Okay, so height shift range. It has to be height shift range. Let's call it again. Hopefully you don't get any errors. But let's look at the model summary. We have like this 26, 26, and 32. How the shape changed from 28, 28 to 26, 26. 32 is because 32 filters. But how is it changed? It's because we it's because of there's a formula. It is like you have the shape, the like we have like 28. We add twice into padding, subtract subtract from the kernel size and divide by stride plus 1. So in this case we have like 28 plus 2p. P padding is 0 in this case. We're going to subtract it from 3 kernel size divided by stride, which is 1 plus 1. So 28 minus 3 divided by 1 plus 1 is 26. Similarly, 26 minus 3 divided by 1, so which is 26. You can also see we want these dependencies from TensorFlow Lite. I will get the links in the description. We also want a draw view where we're gonna draw, and what we want is I will also give the link in the description for this one as well if you don't able to find it. Like I'm clearly struggling, but I'll give the link. Okay, here it is. We want to add this dependency as well as in the root module as well, the this all project one. And what we want is we want another one which is a TF task API. Because we're going to work in a uh, another thread, not the main one. Uh, so what we want is to not get in a don't get stuck. So I'm going to use a task API, and this is the dependency com.google.android services. So I'm going to use this one, and I think the model is compiled. Okay, now you can see the accuracy is like 0.928 and 0.911. So I think it's pretty good. It's not drop of the quantization, so I've not like done inference and all the stuff to see how it's drop, but it's not much. It's good. Okay, so I think the Stack Overflow I will be able to find it. It was here. I think this one 2.0. This one, yeah, this one was the one. This one is what we want, and we'll put the link in the description as always, and for this one as well if you get struggle. So what do you want if you struggle? Let's open Android Studio and create a new project, and this is what you're gonna see. Pretty standard stuff for creating a new project. We'll just what we want is to just first remove this text view from the hello, like this hello world one, and let's go to split code screen and remove this. Okay, so let's first create a layout what you want. Before that, first let's import few dependencies that I talked about earlier. So I sort of close up Firefox, so I have to search it again. So let's copy this GitHub, that's draw view one first, and sync it. So if you want to sync it, it's plus alt enter, and it's going to show you an option like sync now. Just press sync now, and it's going to take some time. It's going to sync. Then other we want is this all project one. Is copy this into the root griddle and sync this one as well. Then after syncing this one, we want the TensorFlow Lite one as well. So just copy that from the link in the description, or just search it yourself. Copy this and paste it here, and uh, run the dependencies. It's gonna take some time, but it's gonna work. So what you want to do is first press com.google.android.gms, and it's gonna show up options. Okay, what you want now is set the layout width and height to width to match parent, height to wrap content. Then we have like what is that? Then set the top constraint to parent uh, by using either going to the layout or just writing the code. Set the ID to draw view. Set the ID to draw view. Then we want is to uh, mm, so let's set the constraint to 1:1. I think uh, that's that be better. And so constraint dot set 1:1. So that's what we want right now. Also, what we want is to set text view to wrap content, and we want the left and right. This is the ID to predict text view. So predict text view, prediction text, and let's set the left and right constraint to parents. Set the right constraint to parent as well, and parent, and we want like the bottom constraint to be at the top of a button. That's gonna be a clear button that I'm gonna make after this one. And let's set text size to 20 sp, and let style also 20 as well, and so bold. We want to top to I think should bottom to top, top to bottom should be uh, okay. This is clearly a mistake here. uh, just change the clear button to like to the ID that I'm gonna to the draw view. This was I'm gonna correct it later, but right now I cannot. This is just a voiceover. I'm gonna realize. I mean, I'm gonna just realize it later. So let's set the left and right constraint of this as well to the parents, and bottom to the bottom should be to the parents as well, and the top one will be connected to the text view. What I want is right to the right, and also uh, text should be like it should print like so I'm creating like this address string clear button, but I clearly don't have that in my string file. So what I do is press alt enter, and it's gonna give me a message like create a resource file, and there I'm gonna like enter what I want. So I'm saying like clear button and press okay, so it's gonna automatically create that in my string file. Okay. And I want what happened, where is that bottom to bottom? Something's clearly wrong here. Okay, so let's create a what I want is I don't want anything to print right here right now, but I do want so let's first edit the main activity, and let's create an empty canvas that I want. So private var draw view, call call it draw view. It's gonna appear. So always press enter because it's then gonna automatically import it into your uh, main activity. Otherwise, you have to manually do it, or you can press alt enter if it's showing red. Then you press alt enter. So say that import it if you have it, but otherwise you don't. So then you need is a and we want the prediction text view as well. This is gonna be like text view, and we're setting all this to null. At this point, as far as those question marks are there, and this. So what we want now is clever not on click listener set on click listener, and I'm gonna call draw view, and let's first do something like clear find view r dot id dot. I forget to mention. I'm gonna forget to link the main activity to the XML link like to yeah sort of like a link like you find view id or id dot predict text view. What's the name? Predict text. Yep, this one. And draw view dot what's that? Is this error? Oh, we forgot the question mark. Prediction text views dot text equal get string r dot string dot. We're going to create a string, so I'm just following the usual routine. Make a string name, variable string name, and then mention the resource what I want to print there. And let's what it's going to do is whenever I press the clear button, it's going to clear the canvas and set the text view to say a particular draw a digit. Also, I'm setting the stroke width to 70f. Set the color to white, so it's going to draw white color. That means I have to change the background color as well. So I'm setting background color to be black. So color I'm going to draw white on a black screen. And let's create a new Kotlin file class. I'm going to call it Digital Classifier. And what we want is to first create few variables. So what I want TensorFlow right now. So I'm going to like say uh, private var interpreter and interpreter. Then I want is to set it to null, and then I want is initialized is a variable, is a boolean variable, and initialize is going to be false. What I'm going to do is from main activity call this is initialized to check if I have successfully able to initialize my interpreter. So you will see what I'm talking about in a moment, but let's first create a function initialize. Let's first create a thread. So I want a private var executive services, and executive services equal to what I want to say is executor services executors. It should be as not only executor. I made it earlier here, but executors dot new cache pool. What I want to do is private var input image a height. This is going to hold the height of the input image and set equal to null, 0. Similarly, I'm going to create two more. One is for the width and other is for the model input size, which is nothing but going to be like um, mul- uh, multiple of input image height, input width height, and multiplied by 4 for float. And you will see what I'm talking about when I'll be using the gradient classifier function. But let's first create a initialize function, and there we will be doing like this. I need to import the task API first. The task API dependency. Forget that. So let's copy this and I think there's some error in the level. I've compiled the code, but I run the code, but there's some issues there. Let's print it here and sync this one. So it said it is successful. So I think it's gonna work. Yeah, you can see. I think like I mentioned earlier, like I messed up with the constraints there. So let's fix those constraints. Uh, let's add task here. This is going to be helpful when I'm running an worker in my like for another thread. So let's add like this bottom to the top of. So the bottom constraint is going to be to the top of the prediction text view or prediction text. And one more thing that I want to add is set height is equal to 0 dp to track content, and then it's fixed. It's basically now solved. And id clear button. Should top to bottom, that was supposed to be like that only. Top to the bottom of, okay, that makes sense now. What we want now is to first call a function of task that's going to be helping us when we are executing that new cache pool thread that we called above, remember. So we're going to call it task complete source, and we also mentioned that we don't want anything to return, so we're going to mention it like a void. And then I'm going to set is like executor.execute executor services.execute, and in here we're gonna call try catch statement first. I'm set a try catch statement. If we have an error that is an input exception, so we're gonna print get it like try task dot set exception e. Otherwise, we're gonna first call a function. So initialize interpreter, and there we're gonna almost there we are gonna initialize it. Believe me, we are gonna. Then we have this task or set result which is null at this point, and we're gonna return task dot task, which is standard here in this case. Then we're gonna let's first create this initialize interpreter function. Okay, after that, what we want is I think it's going to return. We want context first, so we want to set like val private val context because from we want the asset manager, because in the assets we are gonna store our we're gonna create a we haven't created file folder assets right now. Uh, I will later. From the but what we want is we will be storing the our TensorFlow model that we created in our assets folder. And what we're going to do is a val model, load model, and we're gonna create another function load model file where we're gonna load our TensorFlow model. Yeah, this is the last step. This is the end of the initializing. So let's first create load model and private final function, private function load model, and we want asset manager as well as the as well as a string file name, which is a string, and we will return the byte buffer, which is going to be our select model. So we will return a byte buffer here, and let's load our model, which is very standard way of loading it, which is like val file descriptor equal to asset manager. I've also done this same way with the last tutorial video. We have this file descriptor, open file empty file name. Similarly, we want input stream, so file um, file input stream. Uh, I I here file input stream, and we will mention the file descriptor here, dot descriptor file descriptor. Then we want file channel, which is going to be uh, like equal to input stream dot channel, and we want val we want start offset, which is and the declared variable as well. So that we will get from descriptor as well. So we want these, and then we will return a byte of declare length is equal to file descriptor dot declare length, return file channel dot map, and file channel dot map mode dot read only, and mention also pass the sort of declare length, sort of set and declare length as well. And this is going to return a model, and then we're going to do some stuff with the model. First, we want to enable an API. So we will first get the options from our interpreter, so interpreter options, and from there we're gonna set use neural network API. It's gonna speed up processing. Uh, Otherwise, it's gonna take a lot of time. So we want to set it true. We want interpreter model options, and what we want now is uh, we want input shape, and from the input shape we're gonna get our input image height and width, and from the input image height and width we can also get the model size as well. So this is going to be very important when we want to reshape the bitmap that we're going to get from the canvas. So that's why we'll be using this image height and width. One and model input size is equal to float type. I'm going to create a companion in this while in the companion object of this movement. This is going to hold a value 4 and a pixel value which is going to hold a value 1. And let's create this first. So pixel value 4 and 1, sorry, and float type is going to hold value 4. Float type is equal to 4. I forget to mention, like, it's a private val, and here also private val. Let's also create a private val which is going to be like output category constant. I have to mention also the other two are also constant, so I forgot to do that. Output class which is also very true. This is going to be mentioned in when I will be creating a because the output that I want is going to hold like 10 values, so I'm going to mention it there. So what I want is this interpreter is equal to interpreter, and is initialize equal to true. So here I'm going to set true. The only way is initialize going to be true is when I'm successfully able to follow all these steps. If there's an error in between, is initialize not going to be true, and I will be able to get that the is initialize is false. we're also going to close we're also going to close this execute then I'm going to pass when I'm going to destroy my activity. So I'm going to mention it or call it from my on destroy function in the main activity. Also I'm going to create this class async function that I'm also going to call for my main activity, and from the main activity I'm going to pass this async pass this image that I'm going to get from my canvas, and I will return a string which is going to say the prediction as well as the confidence that it has, the prediction as well as the confidence has in it. And we are on a val task, so we're gonna put like okay, standard stuff execute result classify bitmap. Also let's create this result dot, so we're gonna pass the result after this that we're gonna get. So we're gonna set the result to result that we're gonna get from the classify function. Classify is also gonna return the string, that's what we're gonna uh, uh, pass then after result with in the return task or task. So what we want is we are having a bitmap image and we're going to pass and return a string. So we're first going to check is initialize is true, because there is a little bit tiny chance that is initialize is still not called. So we're not going to take that chance. So we're going to set check, if not then escape, otherwise let's continue. And then I'm going to resize the image. I'm going to create a function. I'm not going to create a function, I'm going to pass bitmap, the input image width, input image height, and filter through. It's going to resize the image. I'm going to pass this resize bitmap image, and I'm going to convert this to a byte buffer. And so I'm going to create a function called byte buffer. I'm going to pass this resize image there. So let's create that first. So I'm going to call it convert byte buffer, and I'm going to have like a bitmap image, and I'm going to output a byte buffer. That's what I want here. That's what I want. Okay, a lot of stuff. So first I want to have like I want to allocate the space of byte buffer dot direct allocate direct. Then I'm going to set the alternative. So while but for order byte order dot native, byte order dot native, and what I want now is get the pixels. So this gonna get input array and input dot image width into input dot image height, and I want uh, bitmap dot get pixels. Also in the also this is like an RGB image that I'm gonna bitmap image I'm gonna get. So I have to normalize this as well. So this is gonna be get pixels, and I have to pass stride 0 start width and height and pixels that I'm gonna get from the array. And what I'm gonna do is put pixels in pixel value. So what I'm doing is for R for pixel value SHR and 16 and 0 FF. Similarly, if for G and for blue it's only 0 FF, and for R it's 8 and 0 FF 0 XFF. Uh, yep. This is and then we're gonna just normalize it by adding RGB divided by 3.0, and for for one equal to grayscale, and then normalize it by dividing it to 25 to 55.0 like mentioned earlier. Then byte order dot put the put float, and we're gonna just normalize pixel. We're gonna put this normalize pixel there and return the byte buffer there. Okay, so we are finally done with returning the buffer. Then I'm gonna have the buffer, and now let's see how we're gonna get the output. So I'm gonna do some predictions. So I'm gonna get that after I get the byte buffer, I want an output. So I'm gonna get an array one float. I'm gonna set the float array to the output category that I mentioned earlier, output class that I mentioned earlier. Then I want to run the interpreter. So I'm gonna run interpreter and pass byte buffer as the output. Then I'm going to see is I'm going to check the maximum value that hold. So the maximum the maximum possibility, the prediction, what it says in that particular output, and that's what I'm check for. So val index, and so the what I'm going to do is result dot indices dot max by. It's going to tell what's the maximum value, and using max by I'm going to get what I want. So I'm going to iterate using result it, and in case there is some issues I'm going to put like -1 if there's nothing, no value there. Put a colon there, I think. Yeah, and what I'm going to do is then I should just return it now. Okay, so first print get a result string. This result string is going to hold the string that I want. So I'm going to have a prediction modulus prediction result modulus t integer, and I want confidence as well. Confidence is equal to modulus 2 if it's a float there, and what I want to is dot format and mention. So max index is going to tell us the digit that we're predicting, and result max index is going to tell us the confidence that is has in that digit. So yep, that's the one, and we're going to return the result string, and I think we are done. Yeah, that's what I wanted. Let's go back to the main activity, and there we're gonna call a few things. Check if what we want and what we don't want there, and we're pretty close to finishing this project now. I think first let's listen for touch events on the or we had like draw, so draw view dot set on touch events on touch event listener, and what I want to do is uh, I want on listen for set on touch event. So draw view dot on touch event. I always forget the question mark. I don't know why. It's a null. It has sometimes can be null, so that's why I have to mention a question mark there. Don't forget that. That's why it's shooting the red letter. What I want to do is if event dot action is equal to motion event, then motion event dot action. So what I'm going to do is I'm going to draw 9 digits. Suppose I'm going to draw like 6. I'm going to draw 6. I don't want this to listen for when I'm drawing. When I lift my finger after I draw, then it should see that bitmap image and then it's going to pass it. Then classify. I'm going to create a function called classify. Oh, I forgot to create the object. I have to first create a digital classifier and declassify this because you have to pass the context as well. So I'm going to create a classify function, and then I'm going to also set either true here. Yeah, so what we want to create is a classify function, and I forget to mention the true here. Also, I put the question mark there as well. And let's also initialize the digit classifier. So I mean the is initialize function I have to call. I have to call the initialize function, and if there's a failure, then I'm going to print a message that is log de on create. I'm going to say error, print e there, and it should be an error. Yeah, I have to mention in the companion object that log e, that tag on. That's why it's error. What I can do is I have to mention the companion as well. What can I do? So let's use command object and say like private tag. uh, Tag is equal to main activity, and I think that's gonna do it. Main activity, and also uh, I feel listener. Everything is done. I don't need to do much. Yeah, I have to first. Afterward, in the classifier, what I'm going to do is I'm going to first get the bitmap from the draw view, and then I'm going to call two functions. If bitmap is not equal to null, so it should be null. And second thing, I'm going to check is initialize is true or not. If initialize is true and bitmap is not equal to null, then I'm going to call the class async function, and where I'm going to mention where I'm going to pass the value for my. We're going to set like how should I say this? We're gonna pass the bitmap image and return the string, and that string I'm gonna return. I'm gonna set that string that I'm gonna do. I'm gonna like say predict text dot text is equal to that particular string. So it's gonna set the text of the text view of the predict text equal to the text that I am returning from the processing. I know it's after, but yep. So I'm going to return this error prediction text view, and dot text equal get string. I'm going to mention the string here, r dot string dot classify, and what we're going to do is put a header here, and I don't think I'm missing something here. Yep, everything is now to just yeah. I totally forget the asset manager. I mean, I have to add assets here and then paste the tensor and model. It's not going to work. I think what I'm doing. Also, I forgot to create the onStr function as well. So first, let's create the onStr function, and then I'll put the asset manager, and I mean the assets, and then paste our tensor model that we got after we compile the code. Remember. So what we want is digit classifier dot close. So I'm going to call the close function from here, and then what I want to do is it's done, and what I want to do now is yeah, asset manager. Go to new go to folders and create go to asset folder and create asset folder. And what I want to do is this TensorFlow folder that I created earlier. Here I got that. I'm just tensor model. I'm just going to paste it here. So Control V, and it's going to show it in a moment. System is a bit slow right now. Mm, this is the interface that we're getting, and it's a bit slow because I don't know why it's slow right now. Yeah, it's here, paste one, and I'm gonna run it again, and this should work now. Fingers crossed. But it should. Uh, all those memes about it should run now is not to be trusted, but it should work like it's not. Yeah, it's a success. I don't know what is wrong with my emulator right now, but let's wait. Um, what I'm oh yeah, the name is wrong here. I actually when I was saving I think so I write the name as MINST rather than MNIST, so I mentioned here MNIST. I thought I named it that. I made a lot of typos today. I shouldn't have, but it's success. Oh, it's finally success, and it should. Okay, this is the last time. It is going to run now. Yeah, I'm sure. Okay, so let's draw 3 here, and yeah, it's 0.99 accuracy, and let's draw some other thing. I guess 1 is accurate. Measure it 7. Right, again shift a bit. Yep, let's draw an 8 like this, and it's still very sure about this. So I think we can say like this is a success. And guys, if you like this video, then please consider subscribing, press the bell icon, and I hope I see you in my next video. Get me to 70, please. Give me 70 subs. Well, thanks for watching, and I hope whenever I post my next video, see you.